Alright, so here I'm going to go through some examples of how to graph these with a different a value. You can also check out example A in the book. So for this first one, we have y equals 2 times the sine of x. So when I look at that, the first thing I'm going to do is note that the period is still 2 pi. So far nothing we've done has changed that. The amplitude would be the absolute value of 2, or just 2. So that a value we learned is affecting amplitude. And our midline is still y equals 0. Because again, nothing at this point has shifted that in all that exploration we've done. So what I'm going to do to graph these is I'm going to take my parent function, all my quadrantal angles, and I've got my 0, 1, 0, negative 1, 0. And I'm going to double all my y's, just like I would for a vertical stretch. Right, because that's essentially what amplitude's doing. It's stretching the graph vertically. So I've got 0, 2, 0, negative 2, 0. So when I go to sketch this graph, I'm going to get at least one complete cycle. So I'm going to kind of space it out using my quadrantal angles, that pi over 2, pi, 3 pi over 2, 2 pi. And what I'm going to do then is I'm going to just plot my points, right? My amplitude is kicking me up to 2. Right, so I'm scaling my y's from negative 2 to 2 now. So I've got 0, 0. Let's use a different color just so you can clearly see it. We've got pi over 2, 2. We've got pi 0. 3 pi over 2, negative 2. 2 pi 0. Then I'm going to connect those with a smooth curve. And I would be done. Now sometimes it's going to ask you to lightly sketch the parent graph too. So if we wanted to add the parent graph, we could. And I'll add my parent graph in this light blue. So 0, 0. We've got the pi over 2, 1, pi, 2 pi over 2, negative 1, and 2 pi. So again, just kind of visually seeing that vertical stretch. And if you wanted to do B and C, you notice similar things happening. I don't, want to go through this a ton, but just so you guys kind of get the idea. Right, in B, now our amplitude is changing to 1/2. So what that's going to do is now affect our high-lows again. So instead of multiplying all our y's by 2, for B we would still have a period of 2 pi. Our amplitude would now be the absolute value of 1/2. 1/2. And our midline would still be 0. So normally we would sketch it on a new graph. I'm going to show all of mine on the same graph. So let's get a little bit thicker green there. There we go. So again, when I graph these, I've got, oops, I didn't want to delete that whole line, sorry. And so I'm going to take my parent that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And 0, 1, 0, negative 1, 0. And we're going to multiply them all by 1/2. So we get 0, 1/2, 0, negative 1/2, 0. Right, so we're still starting at 0, 0. Now we're only going up 1/2, back to 0, down 1/2, back to 0. So in retrospect, maybe that thick highlighter was not a great idea for the parent function. So we'll get that in a little blue. Just so you can clearly see that's going up to 1, down to -1. Alright. And then if you were to do C, it's going to be pretty much the same. Right, we'll do a separate graph for C, because this one's a little bit more interesting, I would say, than the rest. I don't know why that moved. Alright. So if you look at C, you've got that -1 in the front. And that's going to do the same thing negatives did before. That's going to reflect our graph. Right, so our period, again, is unchanged. Amplitude is still absolute value, so the amplitude here would be 1. Midline is unchanged. And what I'm going to do is I'm going to take that parent, this on here, and I'm going to multiply all of those y values by -1 now. So we get 0, -1, 0, +1, 0. Alright, so let's sketch this out. So again, I've got my period of 2 pi, so I'm going to put my 2 pi all the way out, my quadrantal angles going down the line there. I've got an amplitude of 1, so my high-lows are just 1, -1. I've got 0, 0, and this time I go down first. Back to 0, up to 1, back to 0. And so you'll notice it's not actually stretching, it's just flipping or reflecting. And so we can get that parent function back in there. That would normally go up to 1, 0, -1, 0. So it doesn't look all that different. Our high-lows have just flipped. Zeros are still in the same spot. So hopefully, this is making sense. To vertically stretch your sine graph, you multiply the parent function, the y values, by a. So D wants to know, hey, what's the equation of a sine function that has a period of 2 pi, amplitude of 4, midline as 0? So hopefully you guys were able to say, well, look, that amplitude of 4 is just affecting a. So that would just be y equals 4 times the sine of x.